Hello everyone, in this video, I will discuss some types of problems that algorithms in computer science solve. Okay, so our first type of problem is searching. So as the name suggests, it is about searching for a given value or what we call as the search key. So kaning search key mo ni siya'y unsa man nga value ang imong gipangita from a list or a set. So mo na siya atong search key. Some applications which have data that may change more often than the frequency of searches, searching should be done in combination with other two operations. Okay, so natay gitawag operations nga insertion to and removal from the set. So, unsa may pasabot-an na. So, most applications makauban jud na nimo nga if mag-search ka o if maka-search ka ng application, usahay maka-add pug ka or maka-remove pug ka. So, unsa may gamit sa searching sa aning two operations. So, mag-search ka, usahay, kung insert ka, unya, nag-exist na ba kintahin na imong insert? So, dili na na i-insert. So, para makaingon ka nga nag-exist na, i-search ni mo na siya from the list or array or set. Then, if mag-remove sad ka, if you want to remove an element from the set or array or list, you still need to search for that value before nimo siya i-remove. Kung nag-exist ba siya sa imuhang list or set. Okay, so ingana na siya. Then, for example nato, we search or find the index of 9 in the following set of integers. For example, ang atong index starts with 0. So, ang index sa ato ang 9. When we search 9, i-output is 1. Okay. So, next type of problem is sorting. So, kani sorting mo ni siya atong gigamit sa example in our previous video on algorithm and pseudocode. So, unsa maning sorting? This problem concerns with rearranging the data. Okay, so maning keyword rearranging of a given list in increasing or decreasing order. So, the inputs of this problem should be comparable, meaning, ang imuhang array or set or list, ang elements nimo ana should be comparable para makasort kanila. Kaya sa man nimo pag-arrange kung wa kay basihan, kinsay mauna or mawahi. So, the applications to this problem could be ranking internet search results, ranking students by their grades, or sorting words in a dictionary. Okay, for example, sort the following words alphabetically, meaning from A to Z. So, some may be in, others. Makintahin niya ang input. So, our output for that given input is muna ang in, then maybe, then others, then some. The next type of problem is string processing. First, we define first what is a string. It is a sequence of characters from an alphabet. Please take note that the alphabet that we are referring here is not the English alphabet. It relates to the alphabet that we describe in our automata class, denoted as sigma. This string processing problem is sometimes called as string matching problem. So, these are problems which involves the processing of strings. Some applications to this problem include gene sequencing, spell checker, plagiarism detection, spam filters, etc. For example, highlight Java keywords in the following code of strings. So, we process the strings and look for Java keywords. So, the expected output for this example is int it is highlighted, then public string are also highlighted, and car, another car. Okay. Another type of problem is the geometric problem. This problem is about geometric objects like points, lines, and polygons. So what are the applications for this? It include computer graphics and robotics. Example, we will use the convex hull in this example. So what is convex hull in problem? This problem requires us to draw the smallest polygon with all angles less than 80 degrees that will enclose all points in a set. In other words, the resulting polygon should have vertices that all point outwards. Okay, so all vertices should point outwards. Okay, so for example, this is the input with many points here in red. Then the expected output is this. Okay. Another type of problem is graph problem. You might anticipate this problem is all about graphing mathematical equations, but the graphs that we are talking about here are graphs like the ones we discuss in or we will discuss in automata class. So a graph consists of edges, which are line segments that connect points called vertices. Applications of graph problems include social or economic network analysis, event scheduling, among others. For example, we consider the graph below, then determine the second degree contacts of person A. So, second degree contact means A's direct contacts and their immediate contacts. Okay, so contact here is defined by a line that connects two circles. Okay, for example, this is our graph. So we will need to determine the second degree contacts of A. So we will start at A. Then we follow through the edges that connects with A. So D and G and C are the direct contacts of A. Now the second degree contacts are for letter D. Since it is the direct contact of A, its direct contact is the second degree contact of A. So, E is part of the second degree contact of A. Also, since C is the direct contact of A, then its direct contact F is part of the second degree contact of A. Another is this. Since G is a direct contact of A, then its direct contact B is part of the second degree contact of A. All in all, the second degree contacts are C, F, D, E, G, B. Lastly, we have the numerical problems. So according to Levitin, numerical problems are problems that involve mathematical objects of continuous nature. For example, solving equations and systems of equations, computing definite integrals. Can recall your calculus here, evaluating functions. Okay, so if you recall, you also evaluated functions in your college algebra class. Then, for example, we evaluate p of x equals 2x to the power of 4 minus x cubed plus 3x squared plus x minus 5 at x equals 3. So, our expected output or p of 3 equals That is, we substitute the value of x, 3, to this equation. 2 times 3 to the power of 4 minus 3 to the power of 3 plus 3 times 3 to the power 3 squared plus 3 minus 5. So that would result to 160. And that's all for the types of problems that can be solved through algorithms. Thank you for watching.